I'm Davis with 20605A First Class, and I'm going to do a world's robot explanation. We'll start with the drive and ODOM. Drive, 450, 3.25. Front traction, so when we're doing wall stakes, we won't get pushed as hard. And just more stability in driving. 8 wheels, sinking to the tiles less. It is heavier, but the trade-off is worth it. ODOM, horizontal and vertical. Just mounted on little poly gussets, front and back. 2-inch mechanisms, offset by 45, so the flat part is where the corner is on both of them. They are rubber banded down. The rotation sensors are running just the regular. We're not doing a screw joint. We did a shaft. 6-motor drive. It's offset stacked, so it's not actually. I don't even know if you can see it. It's not actually directly on top of the other motor. It's offset, so the intake motor can fit right above the drive motor, so it's not the top drive motor isn't too far forward. The ODOM, each ODOM pod has a piston lifter. So the vertical one has this piston, and the horizontal has that piston right there, and they just lift. So when we go to hang, it is all lifted up. I can drop them, and then it'll drop back down. Guess we can go to Mogo. Mogo is 2 25 mil pistons, just a 3-wide. We did run bare screws instead of like standoffs or like these type screws on the front, so there's like a claw and it digs into the goal a little bit more. Double screw joint connected with the standoff is how we mount that, because a screw can't reach the entire way. So if it goes in, it is an Omni clamp. So if we go to the corner too, and then intake, it just accidentally lifted the ODOM again. Score's pretty good. 6-string guards were pretty dog crap. As you can see, they're loose because they were terrible. Intake is 600 RPM, 1 motor. So the motor is offset backwards. You can probably see it better. So there's a gear that drives this shaft that runs the belt, and then the belt drives these gears that are mounted on both sides because we do double chain our first stage. We do run 3 hooks, just so, and the reason for that is if you're putting a ring on the goal, you don't want a hook underneath picking up a ring also. And so 3 hooks space it out to where the next hook picks up the ring, and then there's not one putting it on the goal. We did run flexi intake. It was helpful, although in semis, when it was lifted like this, twisted in a million ways, both chains did somehow break. We didn't run a ramp. We ran, I guess, forks or like sleds or something. And that just worked better because the hooks were able to go through the forks, and we could like lower the hook stage down. First stage, one unique thing we did was we put bearing or bushings in the poly, so the actual bushing spins as well as the shaft, and that just produces friction a lot. It is mounted at a, I think, 40-degree angle. The front 3-wide is, and that just corner clear made that a lot easier. Triple chain. A lot of questions about this. We did it a different way than some people. Some people would do it around the around this part, and then but we actually went through the hole and then back out through that same hole on the chain, and then put the other high strength chain beside it. This never broke. We ran it on our scoring state bot, and there was about 6 to 8 links that were broken, and never knew it because everything was still zip tied together. But we rebuilt it when we changed the zip tie color and dyed everything black. Our whole structure is mounted through these poly pieces, or Delrin pieces. So the robot is mounted off of that 2x2 right there, and then the L channel goes up. The L channel is actually, here you can see on this side, L channel is not connected to the C channel at all. It is connected to this so you can get the perfect angle for Lady Brown through these gussets, and then it is connected on the bottom and on the top to the intake structure itself. That was really good. Everything was CAD'd, so we knew exactly how it was gonna work. So that was a positive. These never showed any signs of breaking or weakness. I guess we can go over, our doinkers and stuff. What button is it? This is our ring stealer / sweeper. We did not have it banded down. It was just passive. Little piece of poly up top just for the sweeper part. The ring, it would just drive over it, and there was enough weight on the actual bottom part of it that it would fall down and then it could pull it back. This is just wrapped L channel that's boxed. One unique thing we did to mount these is we don't have the piston mounts for the Legacy stuff. We have Legacy pistons, we don't have Legacy mounting stuff. So this is actually a high strength bearing with a brass insert in the middle so a screw can go through it, and then the brass insert rotates in the bearing itself, which was a way we could get around not having those piston mounts. Those are 15 mil pistons mounted on a drilled hole in between those, just loosely screwed in so they can rotate, but it was the perfect distance. We'll go over Goal Stealer next. Our stealer was an active stealer, so it has the 25 mil piston in there to clamp, and then the actual piston to drop it out. It worked really good. We didn't actually use it at Worlds because there was no need to, because no one was rushing, so we didn't have anything to worry about. But same piston mount, identical to the other side. Solenoids are mounted sideways to each other, so if there's ever something wrong with the stealer, we know exactly where to diagnose it. How we got the tubes to deploy and retract is this zip tie mounted through the zip tie that mounts the solenoids, and the tubes are able to rotate through that zip tie, so it acts like a little coil. We have 2 radios. A lot of people don't run 2 radios. It's very beneficial. If one disconnects, a wire messes up, it just automatically swaps to the other one. This limit switch was to change autons, as you can see it. changing the autons. We were able to run one program, and then we had all 13 autons into that, which was nice. We ran cutout 2-inch 60A flex wheels on the 48 tooth gears, and that just gave us the arc we wanted. Now to Lady Brown, it is a 360. It only goes to 23 inches, so we never actually used our full 24. It's 100 RPM direct, not what we wanted, but it works. This is a low profile motor cap. As you can see, it's cut off. There's actually a washer and a low profile mini nut inside. You can buy them off of RoboSource, and that's how this is mounted. So there's actually not the standoff in the motor cap. It is just a washer and a nut and a bolt going through the actual motor cap itself. We ran 36 tooth gears because it was geared. Should have replaced them with lock bars. With these flanges that we cut out, we actually reused them as reinforcement plates on the actual fin part itself. It worked really good. L channel with triangle braces, just to make everything more rigid. Ran a rotation sensor. Our Lady Brown had passive hang attached to it. It was just 2 C channels, and instead of running the little poly things that kept it up, that can break, we ran an L channel that butts up to a little 1/4 inch standoff. So it was a legit hard stop, so nothing was able to get bent. We do have macros for loading, and so it just loads like that, and then when it goes up, it just... And then we have a macro for, where's it at? Descoring the top ring. We can descore down to 3 somehow. Driver's goated, but we had a macro set for the first ring so it could be done as quickly as possible. And then we had a PID and everything built into that, so it was consistent every time. We do have color sort. I'll probably put a video in later for this. It was just a single optical sensor that read it. It worked super consistent when you turn the flashlight on. It was able to read the ring perfectly. Some people ask, how do we get, is our poly laser cut, or do we use a CNC? It is all hand cut, so you don't have to have a laser. You don't have to have anything to actually cut it. Just a pair of scissors and a Dremel, and you can go a long way. One thing we did differently was we ran a 3-wide on the back, and this allowed the goal to have a bigger surface area when it sat down on it, so it wasn't just like a high strength bar or a standoff. This robot is only 27 wide, and so we were able to help the goal center itself in the thing by having these little rollers. This added a structural part because it was a screw joint all the way through, but it was actually it actually rolled, so they were able to act as little funnels. One tank right back here. Battery was mounted on a piece of plastic that just went around stuff, and then we had this little lock that brought down. We had a rubber band, a lock, and the battery clip, so it wasn't really coming out. Brain is on this side. Power button is accessible just by there. All custom wires, so there's no extra wire links. You may be thinking, we have a lot of pistons. How does only these 3 wires work? We actually run an expander on this side of the robot. So we have, you know, double the amount of ports, but also we don't have to run like all of these pistons solenoids across the robot, and that creates failure points. The expander has always worked. What else? These were pretty much just decoration, but they did serve as like a balancer. So when this swung over, it was being pushed down through this and not just there. So it kind of stabilized stuff. The whole Lady Brown structure was braced by this across triangle piece. I'm trying to think if there's anything else. Just, I guess catting helped the biggest part. Just so we knew where everything was. We knew that it was actually going to fit. But yeah, that is our, this last thing I didn't talk about was the piston intake lift. And it's mounted just right there. It's on a zip tie so it can flex, but then it lifts up and down with that zip tie mounted on this. So that's the world's robot. This is the last robot for first class. Sad that it ended like it did, but we did the best we could. So that's the world's robot. If you have any questions, feel free to leave them in the comments, and see y'all.